In the previous video, we discussed LSTM. Today, I am clarifying a few things about the size of the vectors of LSTM. This H sub t is the output of the LSTM, which is known as the hidden state. This is a vector. Whatever the length of this vector is, the length of the vector C sub t, which stands for the cell state, is the same. That is, the length of H sub t is equal to the length of C sub t. This C sub t minus 1 is the previous cell state. Therefore, the length of C sub t and length of C sub t minus 1 are the same. Similarly, H sub t is the latest hidden state, or the current input. For the previous input, the hidden state was H sub t minus 1. So the length of H sub t and the length of H sub t minus 1 are the same. The length of X sub t depends on the representation of the current input. If we are using words in a sequence, then X sub t represents the embedding vector for this particular word. So whatever the number of features is in the embedding space, the length of X sub t would be that number. So the length of X sub t depends on the number of features in the embedding space. Now notice here that the number of neurons in the forget gate will also be equal to the length of H sub t, which is also the length of C sub t minus 1. Why is that? Because we multiply the forget gate output with the previous cell state, and this multiplication is element-wise multiplication. Therefore, the length of C sub t minus 1 and the length of F sub t, which is the output of the forget gate, must be the same. That practically means that the number of neurons here must be the same as the length of C sub t minus 1, which is equal to the length of H sub t. For the same reason, the number of neurons here we have for the update gate will also be equal to the length of H sub t. Here also we will need H sub t number of neurons. Here in the output gate, H sub t number of neurons. The output gate's output here will have exactly the same length as the vector length of H sub t. To summarize, the length of C sub t minus 1 is equal to the length of C sub t is equal to the length of H sub t is equal to the length of H sub t minus 1 is equal to number of neurons we have here is equal to the length of F sub t is equal to the number of neurons we have here is equal to the length of the update gate output is equal to the length of the candidate cell state is equal to the neurons we have here is equal to the neurons we have here in the output gate, so on and so forth. And in a complex neural network, when we understand the size of the vectors, then many things are automatically clarified. I hope this short video is useful. See you soon in another video.